Hi guys, in this video episode we'll be exploring the idea and the concept of rising and falling curves or functions, sometimes referred to as increasing or decreasing curves. Now we have two functions behind me. First we'll work with this one here. It's something we've seen before. It's a parabola, y equals x squared. And I'm going to give you a really cool tool on how to further represent these guys as a new way. Rather than representing it graphically and rather than showing it algebraically, we're going to represent it using sign diagrams. And these sign diagrams, I've already taken the liberty to start them down below here. You might see this red line under here and a red line under here. Now they're really cool tools for representing what a curve is doing, whether it's increasing or decreasing, at a glance. And it's really quick for us to recognize and identify what our curve is doing. So let's have a look at this one. As I said earlier, it's y equals x squared. Now, how do we identify the slope and gradient of something? Well, we can differentiate it, can't we? So if I was to differentiate this curve, and that would equal 2x, wouldn't it? 2x. Now, if I put a positive number there, it will be positive, and if I put a negative number, it will be negative. So we know that there's going to be an increasing part of this curve and a decreasing part of this curve. It'll have both. So which is which? Well, we know this is a positive slope out this way, and that's a negative slope out that way. That's a negative one. So what I like to do is actually look at the graph and mark out what I see. So that's positive, rising, increasing curve, and over here we have falling or decreasing. Some people refer to it as monotonically decreasing or monotonically increasing, but between a certain interval. That means for each corresponding x value, there'll be a corresponding y value that matches that increase or perhaps that decrease. So there's our curve here. So we've got a differential, and we know that when f dash x, f prime x, is greater than 0, it's going to have a rise in it, hasn't it? And when f dash is, or f prime x is less than 0, it's going to have a fall in it. So how do you put that sign diagram together? Well, let's have a look here. Since it's rising on this side, all you have to do is, step number one is mark out a critical point. That could be a stationary point or an inflection. And the point we have is right over here at 0, and we put in a 0 there. Then all you have to do is indicate where it's rising. Well, it's rising over here, so put a big plus sign there. It's rising from x, for the values of x is greater than or equal to 0. That's to the right of the domain. And over here, we simply put a negative sign, a big minus there on the sign diagram, indicating that it's falling or monotonically decreasing. And that's all you have to do here. And if you want to add the sign, it is decreasing for x is less than or equal to 0. Now let's go over to the next diagram we have here. We have a cubic curve. It's the function of y equals x cubed. So is this rising or decreasing? What is this doing? How do we represent it up here or down here on the sign diagram? Well, first of all, let's get the derivative. So f prime of x is equal to 3x squared. Now that's an interesting derivative, given that if I put a negative number into that function, will I get a negative or a positive? It will always be a positive, meaning that this curve from that derivative, from that algebra, tells us that it will always be rising or monotonically increasing. So that's a big clue. But as we look at this graph, because we're given the graph, we could simply put, well, it's rising, I can see that, it's obvious. Just put some plus signs there. And as I look at that being plus all the way across, I'll go to the sign diagram, and now instantly that over here on the right, I'm going to put a big plus on the right of the critical point 0, which is an inflection right there. That's all positive. Now what do I put on the left? It's also rising, isn't it? So on the sign diagram, we simply put another plus sign. So this is monotonically increasing across the whole of domain for all of x. And there you have it.